Welcome, y'all. We're learning about factoring today. So, this lesson is going to be broken into multiple parts just because it's a lot of new information. Not so much new, but it's a lot of information that we want to spend time on specific concepts right now. So, right now, we're going to talk about removing common terms. Factoring. So, factoring means to take things out that are the same in a polynomial to make it simplified. So, for example, this first one here, 12x squared y squared minus 20x squared y. So we always look at the numbers values first. So we look at the 12 and the 20. What's the greatest common factor that can come out of there? What's the biggest number that can divide them evenly? Anybody? Yes, 4. We can factor out a 4. We can take out a 4 out of there. By doing so, this gives us right here a 3, and then right here that gives us a 5. Then we look at the x's. We look with variables, it's a little bit easier. You say, hey, all right, there's 2 x's right here, x squared, and there's 3 x's right here. So what can I take out of both of them at the same time? The most I can take out is 2. I can take out 2 x's, meaning these are all gone, and then I'm left with 1 right here, 1x. Then we look at the y. There's 2 y's right here, there's 1 right here. What's the most I can take out? Just 1 y. So if I take 1 out of here, I'm left with the y. Take 1 right here, I'm gone. So I'm left with this right here, 4x squared y times 3y minus 5x. That's factored out. Let's look at this one right here. So this is a quadnomials. So we start with the same thing. Numerically, what's the most we can take out? Is a 5. Everything is divisible by 5, so we divide everything by 5. X-wise, we can't because this doesn't have 1, and that's it. So that gives us 3x cubed plus 9x squared minus x minus 3. That's factored. Same thing over here. Let's try one more time. So pause, try this yourself, and then I'll work it out. Alright, so numerically, I'm going to take out a negative 5. The reason I'm going to take out a negative 5 is because I try to avoid all the negative signs on this very first leading coefficient. And then variable-wise, that's all I can take. I can't take out an a. So by doing so, I'm left with a positive a squared minus 2a minus 3. The reason this became minus because I took out a negative from here. If you force a negative out of there, that makes this become negative because a negative times a negative is a positive. That makes sense? So we're going to go back in when I'm getting negative 5a squared plus 10a plus 15. So that's why by factoring out a negative 5, that forces these positive to become negative. Alright, so that's just factoring in general. But now let's talk about factoring trinomials. So I get trinomials are these polynomials that have 3 different parts. Now in a trinomial with the leading coefficient is 1, those are the ones we're specifically talking about right now, today. When a leading coefficient of 1, there's this value, there's this linear value, and then there's this constant value. There's this b and c, and they're color-coded for a reason. Most trinomials, we'll say about 99% of them, can be factored into 2 binomials, this and this. Okay. Now, what's important about this is these positions here. These numbers are in this spot. If I were to multiply the value of p with q, I get that value c in this spot. But if I were to add those 2 values, I get this value b in this spot, this linear term. So looking at this, this is our b, this is our c. So I'm looking for some value p times q. It gives me the value of 6, and that same value p plus q gives me the value of 5 in this case. So as we factor this, we say, all right, what times what gives me x squared? That's pretty simple, x times x. Now these both are positive, so that means this is positive and this is positive. So then the question is, what 2 numbers multiply to be 6? Well, there's actually multiple values. There's 1 and 6, but then there's also 2 and 3. And that's it. Let's go with 2 and 3. 2 and 3. So 2 times 3 gives me 6. Good. Now, is that the answer? Well, let's double check. Does 2 plus 3 give me 5? Yeah. 2, 3. The reason it's not 6, 1 and 6 is 1 times 6 does give me 6, but 1 plus 6 does not give me 5. So that's why it's for sure not that. So it's 2 and 3. This is factored. So this term right here has been factored down to this. So the question you ask is what times what gives me this? But what plus what gives me this? Exact same numbers. These have to be the exact same numbers right here. Let's try that again right here. So first question, can we take anything out of this problem? We can. They all have at least 2 x's in it, so we can factor out an x squared. We factor out an x squared, that leaves me just x squared in this spot minus 6, and then there's 3, I took out 2, so this is an x plus 8, there's 2 right there, I took out 2, so I'm left with nothing. Now, the question is, what times what gives me 8, and then what plus what? Those same numbers give me 6, negative 6 to be exact. So here's the thing, these two numbers are adding up to be a negative 6, but they multiply to be a positive. How can we get two numbers to add up to a negative, but then also multiply to be a positive 8? Well, we do that by them both being negative. So since we know they're both going to be negative, when we factor this out, what times what gives me x squared? X times x. That means these middle terms right here, the middle signs, will also be negatives. All right, so let's think. There's all factors of 8. There's 1 and 8, 2 and 4. Which ones do you think it's going to be? Okay. Well, 1 times 8, does that give me 8? Yes, but 1 plus 8, does that give me 8? 6. No. 2 and 4. Negative 2 times negative 4, does that give me 8? Yeah. Negative 2 plus negative 4, does that give me 6? Yeah. So we get a 2 and a 4 right there. And again, bring this down. To complete the problem, we have to keep that in there because we did factor that out at one point. Alright, so you guys go ahead and pause and try this one right here. So when we're doing this, same thing as always. Can we take anything out of this? Numerically, yes. We all can take out at least a 2. Can we take out x's? Nope. Can we take out y's? No. So 2. So by doing so, we're left with x squared plus xy minus 12y squared. Now this one, it's only different than the other ones by the fact that it has an extra variable. And that's okay. Just like our problem, what times what gives me x squared? X times x. And same thing here, what times what gives me y squared? Y times y. Now the numbers, those are the math we're going to do. So what two numbers multiply to be a negative 12, but those same two numbers add up to be 1. Yeah, the constant in front of this, the coefficient is a 1. It's 1 xy. So let's look at all factors of 12. We got 1 and 12, 2 and 6, 3 and 4. That's it. So is there any way I can subtract these? Here's the thing. They multiply to be a negative. That means one's negative and one has to be positive. But when I add them up, they give me positive 1. So is any of these, if I subtract them, be negative 1? Or give me a difference of 1? Well, 12 minus 1, 11. 6 minus 2, get 11 right here. 6 minus 2, that gives me 4. Negative 3 plus 4, 1. There we go. So we get negative 3 right here, 4 right there. So then negative 3 plus 4. Negative 3 times 4, negative 12. Negative 3 plus 4, 1. So then that goes right here, minus 3 plus 4. Right now, it doesn't matter which one goes first strictly because our leading coefficient is 1. Once this coefficient changes, then it'll be a different problem. So that's for a different day. All right, last one that we'll practice here. Last one, same thing right here. So can we factor anything out of this? No, 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 no. So the two questions we asked is what times what equals negative 21, and in those same numbers, what plus what equals negative 4. So the only way you can ever multiply two numbers to be a negative is if one's positive and one's negative. So how do we know which one's the positive and which is the negative one? Let's find out. If we add them up and they give you a negative number, that means the bigger number has to be the negative. smaller number will be the positive. So let's factor 21. We got 1 and 21, 3 and 7, as far as it goes. I think if you're you guys are pretty smart, which one do you think it is? Well, let's try 3 and 7. So positive 3 times a negative 7, negative 21. Positive 3 plus a negative 7 is negative 4. There you go. So what times what gives me y squared? So what times what gives me y squared? Y times y. What two numbers multiply to be negative 21 but add up to be negative 4? Positive 3, negative 7. Alright, and that's factoring right there. So we'll stop there for today. We'll look at next lesson. We'll be continuing on.